Hello students, welcome to my channel Elite Maths class. Today I am here with another new topic of class 12. The topic name is determinants. This is a very important topic and chapter of your board syllabus, matrix and determinant. You will get approximately 8 to 10 marks in your board exam, as well as this is a very important chapter in respect of JEE mains or other entrance exams. So these chapters also in JEE mains pattern, when you do say coordinate vectors, there are also application of determinants and matrices. So let's start. Before starting, if you are new to my channel, please subscribe my channel. Let's start today's topic, determinants. Determinants, actually another thing here, matrix and determinants are two correlated chapters. That is, there are some parts in matrix which you can't do without studying determinants, and anyhow determinants is also related to matrices. So before matrix I am starting with determinants, so that while doing matrix it will be very easier for you. So let's start determinants. Actually the concept of determinant is very old, but before introduced by John Carl Friedrich Gauss in 1801, there was the concept of determinants by many mathematicians like Bondermont and Laplace, Lagrange. They did some works on determinants. After that, the modern concept, or that improved, that previous concept was improved by Gauss, and that was published in 1801, and after that it was widely used in mathematics, and it included in mathematics. So we can say that the modern concept of determinant was introduced by Gauss. Now what is the definition of a determinant? Determinant is a real number associated with a square matrix. So this definition is related to matrix. This definition is related to matrix. So I am not explaining determinant by relating to matrix. While I will be doing matrix, then I will explain you how they are related and what are the differences between these two. Now determinant, see the name determinant, literally what determinant means? Determinant means which determines. That's why here some properties are determined by the determinants. That's why it is called, that name was given determinant. Actually Gauss introduced this concept and developed the previous concept while studying quadratic forms. This was first introduced by Gauss while studying quadratic forms. So while studying quadratic forms, determinant was introduced by Gauss, and then there are many applications of determinants in maths. Especially you can find area of a triangle using determinant. You can find volume in vectors also. In vectors you can find cross product, box product, etc. by using determinants. Then you can solve the most important one. You can solve system of linear equation. You can solve system of linear equations using determinants. So these are the uses of determinants in mathematics, and lots of uses are there also in complex numbers. Also determinant is there. And what are the other applications of determinant in science? In various science subjects determinant is applied. Engineering branches determinant is applied. Economics determinant is used. Social science, in the chapter social science, in the subject social science, determinant is also used. So there are wide range of applications of determinants. Now let us start what is a determinant. Before that, two new things we have to know. These two names are row and columns. So before defining determinant, or to give you the concept of determinant, let us know first two things. One is row, one is column. Say you have a set of, so what we are going to know now, row and columns. See, you have a set of parallel lines and the lines are equally distant to each other. So how many parallel lines are there? There are 4 parallel lines. See, I am numbering the lines as 1, 2, 3, 4. See here, you can give the numbers 1, 2, 3, 4. But for determinant or matrix concept, we have to give the numbers as downwards while the lines are horizontal. Then we will be numbering the lines downwards. That is, the above one or the top one will be the first one, second, third, fourth, and so on. Now let us take another set of parallel lines which are again equidistant to each other. I have taken another 4 lines, parallel lines equidistant to each other, such that the second set is perpendicularly intersected to each and one lines of the previous set of parallel lines. Now I am giving the numbers as 1, 2, 3, 4. That is, here we have to give the numbers from left side to right side. Now see here, same numbers of 2 sets of parallel lines and the lines are equally distant to each other are intersected perpendicularly. That is, each of the angle is 90 degree. Now see, in this intersection, the lines, 2 sets of parallel lines, while they are perpendicularly intersected, how many cross point we are getting? Intersecting point. There will be total 16 point of intersection. 16 point of intersection. Now this was our aim. What is row, what is columns? In this structure, say here I am writing the positions only. So in the here we have 4 position, 1 2 3 4, 1 2 3 4, 1 2 3 4, 1 2 3 4. Each of these positions are equidistant from, say, these 4. If you are considering these 4, this will form a square, this will square, this will form another square, etc. So this is an arrangement. How many positions here? Total 4 into 4, 16 positions. So in these positions, if we put some elements, then this structure is called an arrangement. This arrangement, the previous one, is a matrix. In a different class I will explain matrix. Now what is determinant? So before that, these horizontal rows, these horizontal lines, these are called, these are rows and these are columns. The vertical lines are columns. So this one, first column, second column, third column, fourth column. This one, first row, second row, third row, fourth row. So rows and columns are clear. You always remember the horizontal lines are rows and the vertical lines are columns. Now see this structure. How many positions are there? Total 16 positions. Total how many rows? 4 rows and 4 columns. Now another thing you remember, in a determinant, number of row equal to number of column. It is always in a determinant, number of row equal to number of columns, and this is called order of the determinant. If number of, say, this structure, here number of rows equal to 4 and number of columns equal to 4, so order of this determinant will be 4 only, or it is written as 4 by 4. Now coming to the next point, how a determinant is denoted. I am considering this structure. How many positions are there? 16 positions. I am putting some values in each of the positions. Say it is A1, B1, C1, D1, A2, B2, C2, D2, A3, B3, C3, D3, A4, B4, C4, D4. This structure, whenever it is closed by a sign like this, like a modular sign, then it is the determinant. So this is the notation, like the modular sign. In this way a determinant is denoted. This is the structure of a determinant. So how many rows are there? 1 2 3 4. How many columns? 1 2 3 4 columns. So it is a 4 by 4 determinant. Also it is written as order equal to 4, because in a determinant always number of row equal to number of column, number of row equal to number of column. Here it is 4 by 4, so order is generally called as 4. Order is 4 means there are 4 rows 4 columns. So order 3 means there will be 3 row 3 column. Order 2 means there will be 2 row 2 columns. Now say this one is C1, C2, C3, C4. This one is R1, R2, R3. This one is R4. So see this position here, the element is A1. This is at which position? This is in the intersecting point of first column and first row. So it is written as the position 1 1. I am writing here, this is written as 1 1. See this one is first row second column, so it is written as 1 2, first row second column, and so on. Let it be a, or it is also written as D, also written as del. You can use any of the notations. So this is the structure of a 4 by 4 determinant. In your syllabus actually there are 3 by 3 determinants only, that is 2 by 2 and 3 by 3. 4 by 4 order determinants are not there in your syllabus. So let us start with 2 by 2. Let us start with a 2 by 2 determinant and some properties of 2 by 2 determinant. So according to the position, what we are starting here, second order determinant, that is a determinant of order 2 by 2. Remember always, determinant means number of row equal to number of column, that is 2 by 2, 3 by 3, 4 by 4, etc. In general form, according to that position notation, say the first element is A11, A12, A21, A22. It is in short written as Aij, determinant of Aij, I, j equal to 1 2, as it is of order 2 by 2. Now see, again I am explaining here why it is written as 1 1. This one is first row first column, so this element lies in the position at the intersecting point of first row and first column, so it is written as A11. It is first row second column, so it is A12. Now see this, it is second column, second row first column, second row first column. Here it is second row second column, 2 2. Always here remember that the first one indicates number of row and the second suffix indicates number of column. So this is the general structure of a 2 by 2 determinant. I am writing freshly here, say I am taking the elements as A, B, C, D. Now in a second order determinant, another thing we have to remember, it is called rule of sign. In a 2 by 2 determinant, how many elements are there? 4 elements, that is 4 position, and these are the sign of each position. This is first position or 1 1 position, plus minus according to row or column in which direction you go, all the signs are alternative. Now value of a determinant, value of a 2 by 2 determinant. Value of a 2 by 2 determinant. Say it is a 2 by 2 determinant A, B, C, D. If we consider this as a square, then how many diagonals are there? 2 diagonals. This one is one diagonal, this one is one diagonal. This diagonal is called prime diagonal. Whenever in a determinant we are talking about diagonal, you always remember that diagonal in a determinant means the prime diagonal only. and this one is called, this is another diagonal, this is called secondary diagonal. Okay, now see how the value is find out of a 2 by 2 determinant. Say this is the 2 by 2 determinant, this is the starting position, always remember. Then the value is calculated as, just do the cross multiplication of the prime diagonal elements. So it will be A D, then minus here, then the elements of secondary diagonal, it is C B, AD minus CB. This is the value of the determinant, this one is the value of the determinant. And this process, evaluating the value of a 2 by 2 determinant, this, the process name is butterfly method. This method is called butterfly method. So these are the three things you have to remember for a 2 by 2 determinant. 2 by 2 determinant means there are 2 rows, 2 columns, 4 elements. Then the rule of sign, there are four positions having their own signs, plus, minus, plus, minus. Then how to calculate the value of a second order determinant? This is the way, this is called butterfly method. Just starting from the prime diagonal elements, this into this, multiply the prime diagonal elements, minus multiply product of the secondary diagonal elements. That's all for a 2 by 2 determinant. Now third order determinant, up to this is it in your syllabus, 3 by 3 determinant or determinants of order 3. First see the general structure. It is a 3 by 3 determinant or a determinant of order 3. Order 3 means it is a 3 by 3 determinant. Let del be a 3 by 3 determinant, as order is 3 by 3. So how many elements will be there? There will be 9 elements, that is 9 position. See the in general style of writing, A1 1, A1 2, A1 3. See the meaning, A1 2, that means the element is at the position of intersecting point of first row and second column. So this will be, now we are in the second row, A2 1, A2 2, A2 3, A3 1, A3 2, A3 3. See this one, A3 2, 3 denotes the number of row, that is third row, 2 denotes the number of columns, that means this row, this element lies in the intersecting point of third row and second column. So this is the structure of a 3 by 3 determinant. Now again here for rule of sign for a 3 by 3 determinant, see the what is the rule of sign, how many position? 9 position. 9 position having their own signs, plus minus, plus minus, plus minus, plus minus, plus. Now how to remember? This is the starting position. So from the starting position, either you go through this row or go through this column. See the signs are alternatively positive and negative, plus minus, plus minus, plus minus, plus minus, plus minus. Again if you go through this column, plus minus, plus minus, plus minus, plus minus, plus, say plus minus, plus minus, plus minus, plus. Or another technique to memorize the sign is, you consider the diagonals only. All the diagonal signs are positive, non-diagonal signs are negative. I think this one is very easy to memorize. All the diagonal signs of a 3 by 3 determinant, all the diagonal signs are positive and all the non-diagonal signs are negative. Now the next thing is value of a third order determinant or 3 by 3 determinant, that is how to find the value of this determinant. For this there are two methods. Okay, I am starting again. Set D equal to A, B, C, A1, B1, C1, A2, B2, C2, A3, B3, C3. What we are finding? Value of a determinant of order 3. This is we are finding value of a determinant. This is a 3 by 3 determinant. Now see how to find the value of the determinant. Here to find the value we have to memorize this thing, the sign of a 3 by 3 determinant, plus minus plus, plus minus, plus minus plus. Now this method is called actually minor method. In my next video I will discuss what is minor. This is called minor methods or Laplace expansion method. Another method is there, I am coming. So the first method by which we are finding the value of a 3 by 3 determinant or a determinant of order 3, it is called minor method or Laplace expansion method. Now see, in a determinant, how many rows, determinant of order 3, how many rows and columns are there? There are 3 rows, R1, R2, R3, C1, C2, C3. That is, there are 3 rows and 3 columns. So by this method, either the minor method or the Laplacian expansion method, both are same. By this method you are having 6 ways. You are having 6 ways of expansion. That is, we can expand this determinant by 6 ways, that is in 6 different routes. But in all the routes, if you take any one of them, value will be same. Whatever route you are using, the total value or the final value of the determinant will be same. Now see the process how to expand. Here I am expanding by first row. I am expanding this determinant by first row, that is by this way. Then what will be the value? Now see, if in the first row, what are the signs of the first row? Plus, minus, plus. So position is this one, 1 1. The sign of this position is plus, so you have to write plus first, then write this element. Now see, this element lies in first row and first column, intersecting point of first row, first column. Then which elements are remaining? See, these 4 elements are remaining, and these 4 form a 2 by 2 determinant. Then you have to write B2, C2, B3, C3. So first thing complete. Now as we are expanding this by first row, now see the second element of first row. Second element of first row is B1. You write B1. Then see the sign of the second position, it is minus. So here will be minus B1. Now see, there will be a 2 by 2 determinant. Where B1 is? It is here. Now the position of B1 is the intersecting point of first row and second column. So you delete all the elements of first row, second column. Then 4 elements will be remaining there, and these are A2, C2, A3, C3. This one is done. In the first row, the last element is C1. You write C1. Then the position of the last position is plus. So there will be a plus C1. Now another 2 by 2 determinant will be there. See the position of C1. C1 is here. So C1 lies in first row and third column intersecting point. So you delete all the elements in the first row and third column. So what remains? These 4 elements. These are A2, B2, A3, B3. That's all. If you can do this, then the value of the determinant is this. Now see, next step, it is plus, so no need to write anything else. A1. This is a 2 by 2 determinant. Now how to find the value of a 2 by 2 determinant? By butterfly method, you multiply the prime diagonal elements B2, C3 minus B3, C2 minus B1, A2, C3 minus A3, C2 plus C1, again A2, B3 minus B2, A3. These will be the final value of the determinant. So this is the process Laplacian expansion method or minor method. This is the process how to find the value of a 3/3 determinant. Hope up to this all the concepts are clear. So what is the order of a determinant, how to expand, and the rule of sign. These things are always you have to memorize, always you have to keep in mind. And also the process of expanding a determinant. Here one thing always remember, there are 6 ways to expand a determinant of order 3/3, and you choose that row or column in which maximum zeros are there. In my next video I will show you another technique. This is called Ncert's method. That is the shortcut way of expanding a 3/3 determinant, and some properties also I will be discussing in my next video. Hope this was very helpful for you. If this was very helpful, please like and comment and share the video, and don't forget to subscribe my channel and press the bell icon to get notifications of my further videos. Thank you very much.